Hello everyone, welcome to the Fundamentals of Application Architecture. Before we begin learning how to build applications, I would like to ask you to consider the following question. Why do we build applications? In fact, when we design forms, pages, and configuration processes, the real goal behind them is to accurately convert real-life business objects and business activities into data structures and business processes within the application. In other words, it's about bringing the real business world into the application. To achieve this, we need to focus on three core questions. First question, what data objects do we need to manage? For example, customer information and order records in our business are all part of the data objects. Second question, who will use this data? What permissions should they have? Different roles and responsibilities mean different data access permissions. For example, salespeople may only need to view their own customers, while managers need to view company-wide data. Third question, how is data generated, circulated, and processed within the application? In other words, how do we define business processes within the application to ensure the orderly flow of information and efficient business processing? We can summarize these three questions simply as what, who, and how. These three questions may seem simple, but they form the foundational framework that must be considered when building an application. The core objective of this lesson is to help you understand these fundamental questions, enabling you to systematically map the complex real-world business environment into the application. The course content is not only applicable to HAP, but also to other no-code or traditional development platforms, as the underlying logic is consistent across them. Next, let's discuss the first core question. Which data objects need to be managed? In an application, the data objects we refer to are collections of data of the same type, typically presented in the form of tables. These data objects are crucial in an application. The various interface displays, interactive features, business processes, and statistical reports we commonly see are all centered around data objects. For example, in an order management application, we typically manage customer information, contacts, order details, order line items, and product information, among others. These are data objects. Similarly, in an employee management application, employee personal information, department information, attendance records, and compensation data are all specific data objects. Different software products may use different terms, such as worksheet, database, table, or entity, but they all refer to the same concept: data objects. Let's delve deeper and explore the three levels of data objects. The first level is called the overall entity, which represents a general category of things, corresponding to the form in the application. For example, the employee data object refers to the overall set of all employee information, which is typically stored and managed in an application as a form. It often includes additional tool windows to facilitate adding, querying, updating, or deleting these data. The second level is called the individual entity, corresponding to each specific record in the form. For example, in the employee table, there is an employee named Zhang. Zhang's personal profile information is a specific individual entity, represented as a single record in the form. A detailed page is also provided to display all the detailed information of this record. The third level is entity attributes, corresponding to the fields in the form, which are the specific attributes of each individual. For example, Zhang's department is sales, gender is male, and age is 28. These are represented in the application as fields such as department, gender, and age. Having understood these three levels, let's discuss how to accurately extract data objects from real-world business data. Typically, business data can be divided into four categories. The first category is business entities, which are people, things, and objects that a company continuously manages, such as employees, customers, orders, and products. Identifying them is straightforward. If you can describe them using terms like all employees or all orders, they are likely business entities. The second category is business activities, which are specific actions centered around business entities that create value. Examples include customer visits, product procurement, and equipment maintenance. A notable feature of these activities is that they often take the form of business entity plus verb, such as customer visit or equipment maintenance. The third category is business approvals, which represent internal risk control management actions within an organization, such as contract approvals or expense reimbursement approvals. This type of data typically includes both the data being approved and the approval workflow process, so we also need to create a separate data object for it. The fourth category is business lists, which generally derive from entities, activities, or approvals. A notable characteristic of these lists is that their quantity is not fixed, ranging from 0 to multiple entries. For example, an employee may have multiple work experiences, and a single expense reimbursement form may include multiple expense details. For such lists, we typically create a separate data object and associate it with other data objects as a subform. Let's reinforce these concepts with a specific scenario example. Mega Trading Company. Mega Trading primarily sells office supplies. Last week, employee Zhang visited customer Mr. Wang and successfully secured an order involving various office supplies. Upon returning, Zhang submitted an expense request including expenses for transportation, accommodation, and meals. In this scenario, employee, customer, order, and product are business entities. Customer visit is a business activity. Expense request is a business approval. And order details and expense details are business lists. By breaking down the scenario in this way, we can accurately identify the data objects required for the business. However, data objects do not exist in isolation. They often have associative relationships. Generally, the associative relationships between data objects can be categorized into three types. The first is a one-to-one relationship, such as an order belonging to only one customer, or an order detail corresponding to only one specific product. The second is a one-to-many relationship, such as an order containing multiple detail records. The third is a many-to-many relationship, such as an order involving multiple products or a product being purchased by multiple orders. In such cases, we typically use an intermediate table, such as order details, to indirectly establish the relationship between the two data objects. Once we have determined the data objects and their relationships, we have a clear data model. We typically use an ER diagram, or entity relationship diagram, to visualize this model. Of course, if there is a lot of field information, we can also use tools such as Excel to record more detailed information about each data object. Okay, let's summarize the content of this chapter. First, we have gained a comprehensive understanding of what data objects are and their fundamental role in applications. We have also mastered the three levels of data objects: the overall entity, corresponding to a table; the individual entity, corresponding to each row of records in the table; the entity attributes, corresponding to fields, that is, each column in the table. To better extract data objects, we have also broken them down into 4 categories of business data. These include business entities, business activities, business approvals, and business lists. This helps us quickly identify the data that needs to be managed from actual business operations. Finally, we discussed the 3 types of relationships between data objects: one-to-one, one-to-many, and many-to-many. Understanding these relationships is an important foundation for building data models. The above are the basic concepts and extraction methods of data objects that we need to master. By learning these, we can efficiently build an accurate and useful application. Next, we will discuss the second core issue: roles and permissions. In enterprise management applications, data security and compliance management are of utmost importance. Not everyone should be able to freely access or modify system data. Since each person's role is different, their permissions to access and use data should also vary. Proper permission settings not only ensure data security, but also enhance operational stability and efficiency. To address the complexity of permission management, enterprise management applications widely adopt a permission management method known as Role-Based Access Control, RBAC. This method is simple and effective. We first define roles, then set permissions of these roles, and finally assign users to these roles. This way, administrators no longer need to set permissions for each user individually. Let's take a simple example. In the sales department, there are 2 roles: sales representatives and managers. We can specify that sales representatives can create and view customer records but cannot delete them, while managers have higher permissions and can view all sales data. In this way, we only need to assign the appropriate role to each employee to conveniently manage their access permissions. Permission control can have different levels of granularity. There are two common levels of permission management granularity, from coarse to fine. These are module-level permissions and record-level permissions. Module-level permissions typically refer to access permissions for a specific form or page. Record-level permissions refer to view permissions for a specific record under a specific form or page. Let's use a specific example to illustrate what module-level permissions are. For example, in a sales management application, we allow sales representatives to access the customer table but not the accounting table or project table. Based on the customer table access permissions, we can also control record-level permissions, which are typically managed through the member field within the record. For instance, using the sales representative field in the customer table, we can restrict sales representatives to viewing only the customer information they are assigned to, while managers can view all customer information. In addition to these two levels of permission granularity, there is also a more granular field-level permission granularity. In HAP, field-level permission control can be implemented. For example, in project management, for the same project, project members can view project basic information, while only project managers can view project amount and project budget information. Due to the detailed nature of these product features, we will not elaborate further here. By reasonably utilizing different permission levels, we can ensure application data security while providing employees with a good user experience. Next, we move on to the third core issue: process. The essence of processes is to achieve orderly data flow within the application, thereby effectively handling business operations. In actual enterprise management, data is not static. It continuously transitions from one state to another, forming a complete closed-loop process. This flow process is typically implemented through workflows within the application. We can broadly categorize processes within the application into two types: automated processes and approval processes. First, let's examine automated processes. Automated processes are primarily applied to tasks that are highly repetitive, have fixed rules, and do not require human intervention. For example, when a new employee joins the company, there is no need for the Human Resources Department to manually fill out employee records. The application can automatically create the employee's information records. Another example is when a customer's status changes from potential customer to signed customer, the application automatically sends a notification email to relevant personnel. Yet another example is that every Friday afternoon, the application automatically sends reminders to notify everyone of any tasks that remain uncompleted. These scenarios effectively demonstrate the advantages of automated processes. By presetting business logic, repetitive tasks are automatically executed, freeing employees from tedious tasks and allowing them to focus their energy on more valuable decision-making and judgment. Another type of process is the approval processes. Approval processes are typically used in business scenarios, requiring human decision-making or risk management. They not only ensure clear process steps and defined responsibilities, but also meet internal requirements for risk control and audit trail documentation. For example, when an employee submits an expense request, it may first require approval by the department manager, then review by the finance manager before proceeding to the finance payment process. In the application, such a process typically includes multiple stages such as submitting for approval, approval granted, returned for revision, additional signatures, and notification copies, with each step clearly recording the responsible party and the time of the operation. Another example is the contract signing process. After a salesperson drafts a contract, it may undergo sequential approvals by the sales manager, finance department, and legal department. If any party identifies an issue, they can return the contract to the salesperson for revision, after which the approval process is restarted. In practice, we often need to use both automated processes and approval processes simultaneously to meet the needs of different business scenarios. By appropriately combining these two types of processes, we can fully reflect the company's business management requirements in the application, achieving efficient data flow and business process collaboration. Finally, we also need to pay attention to the key details that enhance user experience. The data objects, user roles, and business processes we discussed earlier form the basic architecture of an application, or its framework. However, to make an application truly user-friendly, there are some often overlooked but critical details beyond the framework. Here, we will focus on three. The first is data visualization. The second is interface design and interaction experience. The third is integration. Data visualization transforms complex, dry data into intuitive, easy-to-understand charts, such as using trend charts to show customer growth, maps to visually present regional sales figures, and pie charts to display task completion rates across departments. This approach not only helps managers make quick decisions, but also motivates employees by allowing them to see the results of their work more intuitively. A good application must not only be feature-rich, but also user-friendly and easy to use. So interface design and user experience are equally critical. For example, forms, buttons, and navigation elements should be arranged logically. Different views should be customized for different roles, allowing managers to see comprehensive information while employees see task information relevant to their roles. Additionally, hiding rarely used fields and using auxiliary controls appropriately can also make operations smoother. In actual operations, businesses often use multiple systems, such as CRM customer systems, ERP enterprise resource systems, financial systems, and so on. Through integration technologies like APIs or webhooks, we can achieve data synchronization and process integration between different systems. For example, after an order is approved, it can be automatically pushed to the financial system for invoicing, and after a travel expense report is approved, it can be automatically pushed to an OA system for archiving. This way, businesses can achieve seamless data connectivity and improve work efficiency. At this point, we have nearly completed the entire Application Architecture Fundamentals course. Let's briefly summarize. To build a complete and efficient application, we need to clarify three basic dimensions. The first dimension is what, which refers to the data objects to be managed and their relationships. The second dimension is who, which involves clarifying user roles and permission controls to ensure data security and efficient management. The third dimension is how, which involves designing business processes to ensure that data flows and is processed in an orderly and efficient manner within the system. After clarifying these three fundamental dimensions, we also need to focus on three key capabilities. First, data visualization, which transforms dry numbers into intuitive business insights. Second, interface design and user experience, which enhance user efficiency and satisfaction. Third, system integration, ensuring efficient data flow and collaboration between multiple systems. Only by truly understanding and implementing these core concepts can we achieve the goal we mentioned at the beginning, accurately and efficiently translating the complex real-world business environment into an application. We hope this course has provided you with a clear understanding of application development, helping you build efficient and user-friendly applications in your future work. Thank you for your watching.